these truths to be self-evident.
That all men are created equal.
As a member of Congress, I get to have a lot of really interesting people in the office, experts on what they're talking about.
This is the podcast
for insights into the issues.
China, bioterrorism, Medicare for all, in-depth discussions.
Breaking it down into simple terms. We hold
these truths. We hold these truths.
With Dan Crenshaw.
The Eagle has landed.
So you hear a lot nowadays about chips and semiconductors. You know, they're a big deal and that somehow Taiwan is involved. The thing is, though, I'm not sure if you know how big of a deal they really are, how much your life depends on them. Semiconductors are probably the most central aspect to all foreign policy discussions and lately domestic discussions in our lifetime. Almost any conflict we talk about now on the world scale gets tied to this problem. Or also how you're listening to this podcast, how you drive to work, and how you wash your dishes. They're pretty much involved in everything. And so my guest today is Chris Miller. He's a professor at my alma mater, Tufts University, just outside of Boston. And his latest book is called Chip War. Chip War tells us how semiconductors came to be important, who made them, why Taiwan matters in all of this, and where we are now. So Chris, welcome, and thanks for being on.
Thanks for having me.
So maybe we can just do some Chips 101 to start out with. What is it? What's a semiconductor? Are they all the same? How are they different? What are we even talking about here?
So a chip is a small piece of silicon in most cases, often the size of your fingernail. And inside of chips are carved millions or often billions of tiny circuits, which flip on and off. When they're on, they produce a 1. When they're off, they produce a 0. And all of the 1s and 0s undergirding all software, all data storage, all digital computing are created by chips. And there's a bunch of different types of chips. Some chips process data like the main processor chip inside of your PC or your smartphone. Others chips remember data. And there's a third category of chips that convert real world signals like optical signals or infrared or audio signals into 1s and 0s so that they can be remembered and processed over time. And there's many different companies that create chips. Some are the commoditized low-end chips that you can find in many different types of devices. Others are ultra specialized. Like chips in smartphones, for example, or in data centers. And roughly speaking, you can measure how advanced a chip is by the number of nanometers that describes its production process. So the smaller the number of nanometers, the more advanced the chip is, because the more tiny circuits you can fit on a given piece of silicon, and thus the more data you can remember or process.
Yeah, I don't want to get too involved in the engineering aspect of this, but I can't help but be curious. Actually, on this podcast, we just had conversation about the potential for quantum computing and how just mind-blowing those kind of chips could be should they start to exist. But the simple 0s and 1s, I mean, one question I've always had from an engineering standpoint, and this goes beyond your knowledge on this issue, it's okay to be like, I really don't know. How are these 0s and 1s even manipulated? How are these transistors manipulated and then their signal understood by whatever computer they're in or whatever device they're in?
Yeah, so a transistor is just a switch that flips on and off. You can apply an electric field to it to turn it on and off. And when you flip it on, a circuit is created. And then when you remove the field and it flips off, a circuit is broken. And computers are able to connect directly with these circuits. And so these circuits flipping on and off produce all of the 1s and the 0s. And the challenge with transistors, they've been around for a long time. The first transistor was invented in 1947. But today, the challenge is to make them very, very small. And so if you buy a new smartphone today, just the main chip will have 10 or 15 billion transistors carved into the chip. And so each one of those will be smaller than the size of a virus. And so manufacturing a billion or 10 billion transistors virus sized with close to perfect accuracy is really the hardest manufacturing challenge that humans have ever undertaken.
How do they do that? With lasers?
Yeah, there's a really complex set of machinery that you need to make advanced chips. And there's a couple of companies, almost all located either in the US, Japan, or the Netherlands, that produce the machine tools that are capable of manipulating the silicon to carve the shapes in question. And these machines are really some of the most complex machines humans have ever made. Hundreds of thousands of components, ultra precise machine parts. And so they involve, just to give you a couple of examples, the flattest mirrors humans have ever made are involved in semiconductor manufacturing. Some of the most powerful lasers ever deployed are involved in making chips. And so it really is ultra specialized, ultra complex manufacturing that makes manufacturing cars or dishwashers look simple by comparison.
Innovation is an interesting thing in that way, because I mean, how did you make the machine tools to begin with? Well, you needed chips. Okay. So it's like they just keep building on each other. And that's the story of innovation, I guess, in the human race. It's sort of this chicken or egg question. What was the first transistor used for?
Well, the first transistors were actually not used for computing. It wasn't until the middle of the 50s that people began putting transistors into computers in a pretty large scale. And the first chip, which is multiple transistors on a single piece of silicon, wasn't invented until the end of the 1950s. In 1958, at Texas Instruments outside of Dallas was the place where the first chip was invented. And quickly thereafter, it became clear that it was by far the most efficient way to produce computing power, because rather than stringing multiple different transistors together separately, you could put multiple on a chip and thereby dramatically reduce failure rates. And so the first major, yeah, go ahead.
Well, I don't want to interrupt you, but I did. So sorry. I mean, I was going to say, so like the first big computers that were, the size of buildings, it's because they were stringing together all these transistors.
That's right. Yeah. Yeah. And individual transistors are much larger in general than lots of tiny transistors put on chips. And one of the key benefits of the chip is that you can miniaturize to a far greater degree.
I see. I'm not even sure what a transistor looks like. I'm not sure I would know what it looks like if I saw it.
Well, today they're measured in the billionths of a meter. So you need a specialized microscope to even identify one.
But back then, like, what was it?
So the earliest transistors were really ungainly devices. They had multiple pieces of wire sticking out from them, different types of metals that were brought together, but they look totally different. They function very differently from transistors that you'd find in an iPhone today.
A common thing we hear about is transistor radios. So like what is the difference between are there other types of radios? What's a transistor radio?
Yeah, so one of the early uses of transistors, which is unrelated to transistors in computing, was to amplify signals. And so you could use a transistor to make a signal louder, for example, or a signal stronger. But that's a very different use. It's really unconnected with the types of transistors that are in a phone or a computer today.
So again, on the history of chips, Texas Instruments invented the first chip, and yet we are not the leader in chip making. What's the history there?
So the first chips at Texas Instruments were used for military systems. The Apollo spacecraft was actually the first system that ordered chips at large scale for the guidance computer to send astronauts to the moon. And after that, there were a number of different missile guidance systems that the Defense Department ordered that required chips to be small enough to fit in the nose cone of the missile. But the industry really grew up between Texas and Silicon Valley. And it was in the 1970s and 80s when Silicon Valley firms converted chips from a pretty specialized device used in mainframe computers to a much more widespread consumer product. And that's why you have companies like Apple and many of the companies that we know emerged out of Silicon Valley, because they took advantage of the chip technology there. But today, the most advanced chips aren't made in the United States. They're made in Taiwan, where there's one company, the Taiwan Semiconductor Manufacturing Company, that produces 90% of the world's most advanced processor chips. So an extraordinary concentration of chip making on one small island just off the coast of China. Yeah,
it's problematic for geopolitical reasons because China's got its eye on Taiwan, and maybe for resources such as chip making, but mostly just because they think Taiwan is theirs. And it's just hard to understand that, but it is the case. So how did we lose out to Taiwan? I don't know if it's losing, but because Taiwan's an ally. But in any case, it'd be nice if we built them here. That's been part of the conversation recently. We passed the CHIPS Act in Congress. It got politicized in a way it shouldn't have been. It was unnecessary. But for the most part, Democrats and Republicans want us to make chips here. There's a little bit of disagreement on what the best incentive structure is for companies to do that. We can get into the politics of that maybe in a little bit and what the legislation does. But it's not a controversial issue necessarily to say we want to build them here. But how did 90% start getting built in Taiwan? What did they do differently that we didn't do over the years?
Yeah, well, there's actually a Texas connection there. There's a businessman named Morris Chang who spent most of his career at Texas Instruments and played a really pivotal role in building up chip manufacturing at TI. He was passed over for the CEO job at Texas Instruments in the 1980s, in what in hindsight was a big business mistake. And one of the things that he'd done at Texas Instruments was opened a couple of assembly facilities in East Asia, including in Taiwan, and gotten to know the Taiwanese government as a result of that. And so they approached him and said, will you help us build a chip industry in Taiwan? And at the time, he was thinking through a new business model for chip making. So before that point, all chips were designed and manufactured by the same company. But he envisioned a new type of company that would only manufacture chips. It would serve multiple different chip design companies, and they could take their designs and he'd do the manufacturing. And that proved to be a brilliant business model because it let him grow the company far larger than otherwise would have been the case. And there are really dramatic economies of scale that accrue to big companies in chip making. And so over the past 30 years, TSMC has become both the world's largest and partly for that reason, the world's most advanced maker of processor chips. And so today it's a critical chip maker for big US firms like Apple, AMD, NVIDIA. They produce many of their key chips in Taiwan with TSMC.
It's an interesting distinction because and a lot of people aren't aware of this. So the US is still by far the leader when it comes to design. I mean, like you said, we got Intel, we got Apple, Google's making chips, right? Everybody's designing these interesting chips. We got the quantum computing companies that are trying to design what they're trying to design. But we don't necessarily manufacture a whole lot of them. I mean, do we manufacture any of them? Where are we at?
We do manufacture a fair number, but it's a smaller share than we used to. 30 years ago, around 30% of the world's chips were made in the US. Today, only around 10% of the world's chips are made in the US. And the fact that a lot of key chip designers in the US are so reliant on production in Taiwan, given the military risks, strikes a lot of people as pretty dangerous. I think if our firms were reliant on chip manufacturing in Switzerland or in New Zealand, we'd be a lot less concerned because the economics have been great for the United States. Our chip design firms are very profitable. It's produced smartphones and PCs that are widely used across the population. The benefits to the US tech industry have been substantial to the way the industry is structured today, but it happens all to be in a pretty precarious location. And that's the key danger right now.
Right. And of course, why it made its way to Congress and beyond. So what did Taiwan do differently? Because this is kind of an interesting story too. I mean, I've never visited Taiwan, but I plan to eventually. But what I understand is that these entire cities are built around this one manufacturing capability.
Yeah, they really realized early on that scaling up, having massive scale was critical to making the economics of the industry work. And the government of Taiwan bent over backwards to make sure that chip making was as easy as possible. So there's been great studies, for example, of how long it takes to get a chip making facility approved in Taiwan versus in the US, get all your permits, your environmental regulations. And it's just far faster in Taiwan than anywhere else in the world, but especially than the United States. And I think the US has really dropped the ball in terms of making life easy for chip makers. And the other aspect is tax policy. It's just been much more tax efficient to build chip making facilities in Taiwan. And a new chip making facility can cost $20 billion. And so the tax treatment of that investment is really critical to making sure that companies can make money after putting so much investment in. And Taiwan's been very careful to make sure that there's nowhere better in the world to build a chip facility.
Yeah, you've got the labor force too, I know is an issue. And so, having your educational institutions right there, I think in working in tandem with the industry is pretty important too.
Yeah, that's
I'm not
right.
sure how well we do that.
No, I think we used to do it better than we do today. And certainly as we try to build up more chip manufacturing in the US, a key question is going to be getting universities and community colleges to work with companies to make sure they have the graduates that they need to staff their facilities.
Yeah. Not everybody wants a hard major, but it's like, it pays off. So maybe it's a good idea. So one of the problems we face is it's not just the tax side of things, or the excessive amount of environmental permitting that any investment, any company has to do to build literally anything in this country. That's kind of a separate conversation, but it always gets in the way, in a way that it doesn't in most other countries. To be honest, I think we have an excess of it, but there's beyond that, there's just the simple subsidies. And, as more and more countries are skeptical, and rightfully skeptical, of China, they want to do this same thing too. And so you're competing with subsidies from our allies like France and Japan, South Korea, I suppose. And the question politically becomes, can we really outcompete everybody on subsidies? At what point does that stop making sense? Are the tax credits enough? And I will say, when we were voting on this bill, the CHIPS Act, when we would talk to the industry, they would say they're a lot more excited about the tax credits than the subsidies that they have to apply for. And so that's why there was a counter bill by Kevin Brady that was just about tax credits, which we liked a little bit better for a number of reasons. You're not picking the winner and loser at that point. You're just saying, look, if you do this, we are neutral. You get the tax credit. If you do this, doesn't matter who you are. So generally, that's just so people listening understand why a lot of Republicans were not really in favor of that methodology on the CHIPS Act. The intent was right, but there was disagreement on the methodology. Well, we are where we are now, and there's been quite a few announcements since the CHIP Act that people building. My question was always, were you going to do it anyway, though? I think you were going to do it. I think you were going to invest in the U.S. anyway. I'm not really, I can't know that one way or the other, but I think you were going to do it anyway. And so, but going back to the kind of the geopolitical problems we face, it doesn't really matter necessarily if we're buying chips from France or Japan. They're not going to be invaded by China or Russia. I mean, not soon. We got a little, you never know. Hence why it's important to stop Russia where they're at. Same with China, but because they've done it before. So, in any case, it's that's why it's a difficult political discussion. And, how much subsidies do we really need? And where will the CHIPS Act, do you think, get us? Are we ever going to be comfortable with what we're manufacturing? Or, what's the conservative estimate on how much we'll increase our manufacturing capabilities?
Yeah, I mean, I agree with how you framed the problem, which is not to necessarily strive for self-sufficiency, but just to focus on the problem of excessive concentration in Taiwan and in China, which is also a growing producer of chips. I think the CHIPS Act is going to make a difference, but not a dramatic difference. We're still going to be buying chips from Taiwan in 5 years' time, I suspect. Just because Taiwan is such a massive producer of chips today. And we're not talking about moving capacity out of Taiwan, but just where we're going to build additional new capacity. And so all of the factories that are already in Taiwan will still be operating and still be supplying US firms that are building cars and dishwashers and smartphones. I think the CHIPS Act is going to move the needle, but it's not going to be transformative in terms of the fact that our electronics and computing supply chains are just really Asia-centric right now. And it's going to take a long time to change that.
Again, we have not a monopoly, but we're by far the leader in design of advanced chips. So that's good for us. But those designs are obviously located in Taiwan physically, right? Because they're the ones building it. So that's proprietary information. How frightened should we be about the security there, especially Chinese constantly trying to steal intellectual property, whether it's directly from Apple or Intel, or they could go to Taiwan and get it there. How worried should we be about that? What steps are they taking to thwart us?
Yeah, it's definitely an issue. And I think it's almost every year that a major chip company reports a big intellectual property theft from China. But one of the things about this industry that's made it hard for China to catch up to the cutting edge is that a lot of the know-how in the industry is not something you can simply copy and paste in a file. There's a lot of really unique, specialized skills in the people designing chips, people manufacturing them, that you really can't steal very easily. And so China's been trying to hire hundreds of engineers, especially from Taiwan, who work on semiconductors over the past decade. And they've made some progress, but in a lot of ways, it's less impressive than you might think. And China's still pretty far behind Taiwan in terms of manufacturing, or the US in terms of chip design and software tools used to design chips, just because it's not copy and pasteable in the way that China might like.
So where does that put them in terms of capabilities? I guess especially on like the AI front, and the weapons front, because I mean they seem still perfectly capable of developing some pretty interesting technology, whether it's hypersonic missiles or their ability to go into space, their AI capabilities. So it kind of begs the question: are we splitting hairs as far as who's more advanced on chips? Does it matter, or why does it matter?
Yeah, so in terms of chip manufacturing in China, they're multiple generations behind Taiwan, 3 or so generations behind, and a generation in chip making involves a doubling in computing power. So if you're multiple generations behind, you're not just a little bit behind, you're far behind. But until really recently, China was able to import most of the chips that it wanted for AI purposes. Until last year, China could access the most advanced AI chips so long as it promised to use them for civilian purposes. And we had lots of great open source information about ways that Chinese firms would claim they're using them for civilian purposes and then repurpose them for military purposes. And so now it's illegal to transfer certain types of chips, especially chips focused on AI, to China. But over the last couple of years, they've imported lots and lots of chips designed by US firms made in Taiwan that are useful for AI. And so right now, China's got a large number of data centers capable of developing pretty advanced AI systems. As the controls that we put in place last year kick in, I think over time, China will struggle to gain access to the next generation and the subsequent generation of AI chips. And that will cause some problems in their ability to develop AI systems efficiently and deploy them across military intelligence uses. But I think, this is not sort of a secret weapon that can really dramatically hold back the Chinese computing industry. It'll hurt them. But as you say, lots of weapon systems don't necessarily require the most cutting edge. You can get by with chips a couple generations behind.
Okay, that's helpful. It begs the question, of course, why didn't we put in those restrictions earlier? If only. It seems like something Trump would have loved to do. It's right up his alley. Did they just not think of it? I don't know how closely you follow the decision-making process.
Yeah, I think for a long time, there was the belief that it was too provocative to stop selling these chips to all of China, including civilian firms. Mm-hmm. And there was the hope that we could really enforce the distinction of selling to civilians, but not selling to the Chinese military. And the practice of the last 10 years suggests that that was just a distinction that was impossible to enforce. And I think in hindsight, a lot of people wish that we'd started enforcing these restrictions a lot sooner.
Right, because it allowed them to basically be in a near peer competition with us without having even to build it themselves. So now we have to wait until we leapfrog ahead, which I assume, should we be optimistic that we will continue to leapfrog ahead and create these supercomputers?
Well, I think so. The historical track record is that we're pretty good at it. And that China has been successful over the last decade because it's been able to import US and Taiwanese made hardware. Mm-hmm. China's domestic capabilities in manufacturing this type of computing hardware are really pretty limited still. And so they might learn to catch up in certain spheres, but I think it's going to be a long slog for them. In the meantime, the combination of the US and Taiwan and Korea and Japan have really a great track record in driving advances year after year.
Yeah, that's interesting. I mean, what more could we do to I think choke them off and decouple? I mean, what in this particular subject matter, what have we not done yet that maybe we should think about doing?
I think the other aspect is making sure that R&D connections between Chinese institutions and firms and foreign institutions are also cut off. The US has taken a lot of steps, but our allies have done less than they probably ought to, whether it's Japan, Korea, Taiwan, Europe. I think a lot of the countries are in following mode, looking to see both what we do, but also what we push them to do. And my sense is that there's a lot more to be done in terms of the twisting of allies' arms to make sure they're fully following the restrictions that we're implementing.
Right. I mean, the veil has been lifted on Chinese intentions. I think across the board, there shouldn't be any more China doves, I suppose you would call them in foreign policy circles, and that is that's a bipartisan, I think, mostly a bipartisan sentiment, which is a good thing. But the question is always again, what exactly do we do? is the private sector doing their part? From all signs, it does seem like the private sector is deliberately decoupling from China for fear of, we don't have to make them. It's just they see the writing on the wall that there's some kind of at least economic conflict, if we're not already in it happening, and that it just makes good business sense to have some kind of decoupling. The one thing you write about your book too, which is interesting, is the people don't realize perhaps is that our advanced chip making was perhaps a large driver of the fall of or winning of the Cold War, the fall of the Soviet Union, our ability to just outpace them so dramatically. I don't know if you want to talk about that for a minute.
Yeah, I think most people think of computing power and they think of PCs or smartphones, but for understanding the way that military power has shifted over the last half century, computing is absolutely at the center. And the US has been better than anyone in the world at applying computing capabilities and sensors and communications to its military. And in terms of the arms race with the Soviet Union, the reason that we won was because in the 1980s, we put a lot of effort into developing new systems based on these advanced computing technologies that really transformed the US military. And I think today too, you see a lot of effort on that exact same question. How do you have more semi-autonomous systems being deployed in the US military? How do you take advantage of new sensors and communications? And I think if you look at the race with China, it will be defined by computing power just as much as the Cold War was.
Yeah, well, we better get on it, huh? And get more people in engineering degrees. How we do that might be a topic for another discussion. But since we're talking about Russia, we're going to move into episode 2. For those listening, that Chris is an expert not just on chips and the history thereof, but also on Russia, and subject I talk about plenty on this podcast, and the question of whether we should be involved at all, what Russia's true intentions are, how we should even think about that problem. And tune in for our next episode for that. Thanks, Chris.
Thanks for having me.